So let's look at learning objective C about computing weighted averages, and I also show you how to use the graphing calculator to compute averages that are weighted. Now here's an example of a grading scale, which is a very similar thing schools are used to, how the letter grades have their weight. For example, an A is a 4.0, a B is a 3.0, a C is a 2.0, and everything in between. Here is Susan's report card. Here are her letter grades. And here are the credits per class. Now, what they want us to do is to compute her GPA. So what people are going to be tempted to do is to say, okay, I can find her GPA. I'm going to take this 4.0 plus the 2.67 plus 3.33 plus 0.67 plus the 2, add them up, and then divide by 5. Now, that would be the average of the 5 classes if all of the classes had the same credit weight. However, they're different. So what you have to do is the weighted average. And what the weighted average says is to do this. Is you have to take the value of her data set times its weight. So what you do here is you say, okay, she got a 4.0, but there is only 1 credit. So you would do 4 times 1 credit. Plus, she got a 2.67 for 5 credits. So we're going to give her 2.67 for the 5 credits. So that gets weighted more. She had a 3.33 for 4 credits. 0.67 for 3 credits. That class didn't go so well. And the last is a 2.0 for 3 credits. Okay. Now be careful. What did we tally up here? This is her GPA, not per class, but her GPA per credit. So down here has to be the number of credits. So if you add up all of her credits here, we're going to end up finding that she has 16 credits here in total. So I'm going to take this whole top number and divide it by 16. When we do that, we're going to tally up everything on the top, divide the answer by 16, and you're going to end up getting a 2.42 is her weighted GPA. So she is coming in somewhere between a C plus and a B minus per credit. Here's another way to use weighted average, but they're not specifically saying that. Alexis wants to buy a ticket to a concert. She saw that the ticket prices were $20, $30, and $100. She wrote to the concert promoters that the average price of $50 is too much for teenagers. Do you agree with her calculation? Now, what Alexa did is, where did she get the $50 from? Well, she came in here and she took 100 plus 30 plus 20 and divided by 3 different types of tickets. Got 150 over 3 and said $50. Now, the problem is the amount of tickets available for here. They're not equally balanced. So she can't do that. That's not a valid calculation. What you have to do is say there were $20 tickets, there were 1,000 of them. Then the $30 tickets, there were 500. Then $100 tickets, there were 20 of them. So we're trying to get the cost per ticket. So this here is going to be the total cost. So when I say per, that means a divide, by the way. And I need all the tickets here. Well, how many tickets were there? If you tally this up, there's going to be 1,520 tickets. So if you do this calculation, what you're going to end up getting is the average price per ticket is going to be $24.34. So she was way off on her calculation. Now, on Alexis' example, what they gave us here, this right here is called a frequency table. Okay, so it's a frequency table, and it's a table of counts. So frequency is the count, and this right here is a count. They want us to do this, is to convert the frequency table to a relative frequency table. So what relative frequency is the percent of the total. So to do that, let me just draw the table down here again. Okay, so here's our table over here where we have the 3 different ticket prices. And instead of putting availability, I put count or frequency. So just to let you remember that that's what that means. So what they want us to do now is to do a relative frequency. And what that is just a percentage. So the relative frequency is a percent of total. Well, I'm going to come down here and say there's 1,520 tickets. So if they want a relative frequency, what are you going to put for the percent? So over here what you would do is you would say what percent of tickets is the 1,000 tickets. Well, it's 1,000 tickets divided by 1,520. As a percentage, that kicks back at a 0.66 decimal place, or about a 67% roughly. Well, how many $30 tickets were there? Well, there's 500 over the total of 1,520. That percent, it kicks back at a decimal of 0.33, about 33%. And then the last one would be 20 over 1520, and that's going to kick back at about 0.01, so approximately 1%. So the relative frequency here can be listed as a percentage or as a decimal. They mean the same thing. The decimal here again is 66%. We'll just keep it at that. So if you did that, it'd be that as a percent. This is a 33%, and this is a 1%. Now, part B on this one is a little interesting. They want us to compute the weighted average of the ticket. We already know it's really about $24, but they want us to use relative frequencies. So here's where these can be handy. Instead of doing what we did before, we went in and said, okay, $20 tickets, I had 1,000, and I added 30 times 500, and I added 100 times 20, added those up, and then we divided by 1,520. Well, you can actually use these relative frequencies. What you would do is very similar. All you do is you're going to take the percent times the ticket value, that percent times that, and add them up. So I could say $20 tickets at 0.66% plus $30 tickets at 0.33% plus $100 tickets at 0.01%. If I do that, I'm going to get the same value of $24.34. So just another way to calculate a weighted average, but this time using relative frequencies versus total counts. Now I do want you to be able to know how to compute the mean again using the calculator, but I'm going to show you how you would do it if you had to make a frequency table. So let's just go back to the wacky widgets and I'll show you what I did. This data here is just a table of data. If I make a frequency table of that, you're going to see it right here. I made a frequency table, and what it is I put here the salaries in the first column, and then the second, because it's frequency we're talking about, I'm just talking about the counts. So I went in and said, okay, how many $24 salaries were there? I counted up, there were 2. 27, there was 1. 30, there were 3. 35, there was 1. So what you can do is you can actually, if you don't want to have to sit and type all of this data into list 1 and then have it kick it out, you can actually type in a frequency table. So here's what you do. You go to Stat, just like we did before, and when you hit on Stat, go to Edit. When you go to Edit, you're going to get the table. Now, instead of just putting all the data in column 1 like we did before, what you would do is type your frequency table so they match up. I would do, again, 24 salaries, there were 2. 27, there was 1. 30, there was 3, and so forth. Then you go back to Stat, and then you're going to hit this time Calculate. We're still going to choose the one variable stat like we did before. But this time you tell it you do have a frequency in one of your columns. So list 1 is L1, or all of my salary data. But my frequency I do have in list 2. So you would put L2. Typically we keep this blank if we're not using a frequency table. Then to calculate, same as before. I'm going to just hit enter, and it's going to kick back the exact same answer as it did before.